Have you ever wondered how frogs strike their prey with tongues faster than a blink? Or how some of these seemingly harmless amphibians hold enough venom to take down predators, even humans? Get ready to uncover the shocking secrets of the world's most dangerous frogs, where beauty meets deadly survival. Stay till the end, because what you're about to discover will change the way you see frogs forever. How frogs hunt. Their prey frogs may look small and harmless, but when it comes to hunting, they are some of the most efficient predators in nature. Their techniques are a combination of patience, precision, and speed, making them highly successful hunters. Unlike other predators that chase their prey, frogs are ambush hunters. They rely on their incredible ability to remain completely still, blending perfectly into their surroundings. Whether hiding among leaves, sitting motionless on a branch, or partially submerged in water, a frog waits patiently for the right moment. But what makes a frog such an effective hunter? It all starts with its extraordinary vision. Frogs have nearly 360-degree eyesight, allowing them to detect even the slightest movement from almost any direction. Their eyes are specially adapted to track small, fast-moving insects, making it almost impossible for prey to escape once spotted. As soon as an unsuspecting insect comes within range, the frog launches its secret weapon, its tongue. A frog's tongue is no ordinary muscle. It is one of the fastest and most efficient hunting tools in the animal kingdom. In less than a fraction of a second, the tongue shoots out, snatches the prey, and pulls it back into the mouth. This happens so fast that the human eye can barely catch the movement. But speed isn't the only thing that makes a frog's tongue deadly. The real secret lies in its saliva. Unlike normal saliva, a frog's saliva changes consistency during hunting. When the tongue strikes the prey, the saliva is thin and runny, allowing it to spread over the insect's body. But the moment the tongue pulls back, the saliva becomes thick and sticky, ensuring the prey remains trapped. This unique adaptation ensures that even the most slippery insects have no chance of escape. Once the prey is caught, it is swallowed whole. Frogs don't chew their food because they lack the proper teeth for grinding. Instead, they use a strange but effective technique, their own eyeballs. When swallowing, a frog's eyes sink down into its head, pressing against the food and helping to push it deeper into the throat. This unusual method allows them to gulp down large meals without any difficulty. But not all frogs hunt the same way. Some species, like the horned frog, have incredibly strong jaws that allow them to capture larger prey, including other frogs, small rodents, and even birds. Others use venom or secrete toxic substances to immobilize their prey before eating. Frogs have perfected the art of hunting over millions of years. Whether it's their razor-sharp reflexes, their super sticky tongues, or their bizarre swallowing techniques, these small creatures are far more dangerous to their prey than they appear. And this is just the beginning. Some frogs are masters of disguise, blending into their surroundings so well that they become nearly invisible. Others can jump astonishing distances to surprise their prey. But how do these adaptations work? And what makes some frogs deadlier than others? Can frogs kill a human? Frogs, small and unassuming, are creatures we often associate with rain-soaked forests, gentle croaks, and harmless leaps across lily pads. They seem innocent, delicate, even fragile, but in nature, appearances can be deceiving. Some frogs hold within them a power that is far greater, far deadlier than their size suggests. A power so potent, so lethal, that it raises a terrifying question. Can a frog kill a human? At first, the idea seems absurd. After all, frogs do not have fangs dripping with venom. They do not possess razor-sharp claws or bone-crushing jaws. They do not stalk prey like wolves, nor do they coil and constrict like snakes. And yet, in the dense jungles of South America, in in the shadowy wetlands of Central Africa, and in the remote forests of Madagascar, certain frogs harbor a secret that makes them some of the deadliest creatures on Earth. The golden poison dart frog, just an inch or two in length, carries enough venom to kill entire groups of humans. This tiny amphibian does not inject its poison with a bite. It does not need to. Its very skin is a weapon. Simply touching this frog is enough to transfer its deadly toxin, a neurotoxic compound called batrachotoxin, into the bloodstream. Batrachotoxin works in a horrifying way. It disrupts the electrical signals that travel between nerves and muscles, locking the body in a state of paralysis. First, the victim loses control of their limbs. Then, their breathing slows as the muscles of the diaphragm fail. Finally, the heart, unable to receive proper signals, ceases to beat. There is no antidote, no reversal. The only hope is immediate medical intervention, and even then, survival is uncertain. This deadly power is not accidental. It has been understood for centuries. Indigenous tribes of Colombia and the surrounding regions have long used the poison of these frogs to coat the tips of their hunting darts, creating weapons so lethal that even a tiny scratch can bring down an animal in moments. They handle the frogs with the utmost care, avoiding direct contact, knowing that a single mistake could be fatal. But the golden poison dart frog is not alone in its deadly capabilities. The blue poison dart frog, though smaller and seemingly more fragile, carries a venom that can cause excruciating pain, muscle contractions, and organ failure. The phantasmal poison frog, one of the rarest, secretes toxins so potent that even microscopic amounts can cause seizures and death. And then there are frogs that do not kill with poison, but with sheer force. The African bullfrog, an aggressive and territorial species, has been known to attack when provoked. With powerful jaws capable of delivering a bone-crushing bite, it can inflict deep wounds and infections that, if untreated, can turn deadly. Yet, perhaps the most chilling fact is that these deadly frogs do not even create their own poison. They harvest it. Their diets, consisting of highly toxic ants, mites, and small venomous insects, allow them to absorb and refine their chemical defenses. This means that in captivity, when fed a controlled diet, they become harmless. But in the wild, where they feast upon their natural prey, they are walking biological weapons. This brings forth an eerie thought. If a creature so small, so unassuming, can wield such devastating power, what other secrets does the frog kingdom hold? Could there be even more deadly species lurking undiscovered in the rainforests? Could nature have created frogs even more toxic, more lethal than those we already know? And beyond their deadly potential, there is another mystery, one that has fascinated scientists for centuries. Because when the sun sets, when the world is cloaked in darkness, frogs do something extraordinary. They fill the night with sound, creating an otherworldly chorus that stretches for miles. But why do they do it? What are they saying? And how do such tiny creatures produce sounds so powerful that they can echo through an entire forest? The most dangerous frogs on Earth. Not all frogs are deadly to humans, but among them, there exist creatures so toxic, so dangerously potent, that even the lightest touch could mean death. Their skins, seemingly smooth and unthreatening, hold within them a chemical arsenal capable of shutting down the body's most vital functions. These are not the frogs found in backyard ponds or lazy streams. These are nature's silent assassins. The most dangerous frogs on Earth do not roar, do not chase, do not strike with fangs or claws. They kill with chemistry. At the top of this lethal hierarchy sits the golden poison dart frog. Found in the rainforests of Colombia, this tiny bright yellow amphibian carries enough venom to kill dozens of fully grown humans. It does not need to bite. It does not need to fight. It simply exists, its skin saturated with batrachotoxin, a neurotoxin so powerful that it can stop the heart in minutes. Indigenous tribes have long understood its potential, carefully extracting the venom and applying it to their blow darts, creating weapons that can bring down animals in an instant. But even without human intervention, this frog is nature's own executioner. A single touch, the briefest moment of contact, can be enough to deliver a fatal dose, and yet, the golden poison dart frog is not alone. Across the dense forests of South America, other species lurk, each wielding their own biochemical weapons. The blue poison dart frog, its vibrant electric hue a warning to all who come near. The black-legged poison frog, small and unassuming, yet lethal beyond measure. The phantasmal poison frog, so rare, so elusive, yet possessing toxins that can cause seizures, hallucinations, and even death. But what makes these frogs so dangerous is not just their venom, it is the way they acquire it. These amphibians are not born deadly. Their toxic power comes from their diet, a collection of ants, mites, and other poisonous insects that they consume over time. Their bodies absorb and refine these chemical defenses, concentrating them into a biological weapon. Take these frogs out of the wild, feed them ordinary food, and their lethal nature fades away. They become harmless, stripped of their toxic strength. However, not all dangerous frogs rely on poison. Some, like the Amazonian horned frog, kill through sheer brute force. Its massive, oversized mouth can deliver an iron grip bite strong enough to break the bones of small animals. This species does not use venom to hunt. It does not need to. Instead, it relies on ambush tactics, waiting motionless in the undergrowth, striking with a crushing snap of its jaws. And then, there are the frogs that blend both worlds, those that use venom in ways more sinister than simple skin contact. The Bruno's casque-headed frog, found in Brazil, does something that seems almost unnatural. It has evolved spines hidden within its skull, sharp enough to pierce human skin, capable of injecting toxins directly into the bloodstream, a defense mechanism so rare, so precise, that it has been studied for its unique adaptation in the evolutionary arms race of survival. Each of these frogs, whether through venom or brute strength, stands as a testament to nature's ability to create danger in the most unexpected forms. But while some are deadly, others have developed a power that is not meant to kill, but to communicate. Because when night falls and the world is cloaked in darkness, frogs transform into something else entirely. They begin to sing, not with words, but with echoes, with vibrations, with sounds so powerful they can fill entire forests. But why? What are they saying? And how do such tiny creatures create sounds that can travel for miles, creating a chorus that dominates the night? How frogs make sounds at night. When night falls, when the world slips into darkness, the forests do not fall silent. Instead, they come alive with an ancient rhythmic symphony, one that has echoed through jungles, swamps, and wetlands for millions of years. It is not the howl of wolves, nor the whisper of the wind. It is the call of the frogs. But this is not just noise. It is a language, a coded message passed through sound waves, a conversation carried across miles of thick vegetation. Some calls are deep and resonant, vibrating through the air like distant drums. Others are high-pitched, sharp, like a rapid pulse cutting through the silence. Each sound, each note has meaning. Frogs do not sing for pleasure. They sing for survival. At the heart of this nocturnal chorus is one primary goal: attraction. Male frogs call into the night to announce their presence, advertising themselves to potential mates. But this is no simple love song. It is a declaration of strength, a display of stamina, a test of endurance. The longer a male can call, the more attractive he appears. A strong, steady voice signals good health, resilience, and genetic superiority. A weak or faltering call, it can mean the difference between passing on one's lineage or being ignored altogether. But attracting a mate is not the only reason frogs vocalize. Some calls are warnings, territorial threats meant to ward off rivals. In crowded breeding grounds where dozens, sometimes hundreds, of males gather, competition is fierce. A frog's call is not just an invitation, it is a challenge. It tells others, this space is mine. If a rival dares to intrude, a different kind of call emerges, one not meant for courtship, but for combat. And then there are the distress calls. The desperate, sharp cries that cut through the night when a frog is caught in the jaws of a predator. These sounds are sudden, piercing, designed to startle, to confuse, to buy even the smallest chance of escape. In some species, this scream is so jarring, so unexpected, that it can cause a moment of hesitation in an attacking snake, bird, or mammal. Just enough time for the frog to break free and disappear into the darkness. But how do these creatures, small and fragile, produce sounds that can travel such vast distances? The secret lies in a specialized structure known as the vocal sac. This thin, elastic membrane, located beneath the chin, acts like a natural amplifier. When a frog calls, air is pushed from the lungs into the vocal sac, causing it to inflate like a balloon. The vibration of this air creates sound, and the expansion of the sac projects it outward, sending it rippling across the landscape. Different species have evolved different methods to enhance their calls. Some frogs, like the massive American bullfrog, rely on deep, resonant bellows that carry over long distances. Others, like the tiny spring peeper, produce high-frequency chirps that can pierce through dense vegetation. The variety of frog calls is astonishing, with some species even using ultrasonic frequencies, sounds so high-pitched that they are beyond the range of human hearing. But perhaps the most remarkable thing about these sounds is not how they are made, but how ancient they are. For millions of years, long before the first humans ever set foot on Earth, long before even the dinosaurs walked the land, frogs have been calling into the night. Their voices have carried through prehistoric swamps, across ancient rainforests, through ice ages and mass extinctions. They are a living echo of the past, a reminder that the story of frogs is far older, far deeper than we can even begin to imagine. But where did this story begin? How did these creatures, these masters of both land and water, come to be? To understand the true origin of frogs, we must journey back, farther than we have ever gone before, back to a time when the world was unrecognizable, when strange creatures ruled the planet, and when the first frogs took their very first leap into existence. The origin of frogs. Before the world sounded with the calls of frogs, before their voices echoed through rainforests and wetlands, before they became the masters of land and water, there was a time when they did not exist at all. To uncover the origins of frogs, we must turn back the clock, far beyond human history, beyond the time of mammals, beyond even the mighty dinosaurs. We must go back hundreds of millions of years to an Earth that was unrecognizable, an Earth where life was still finding its way from the depths of the oceans onto solid ground. The story of frogs begins in the Devonian period, a time when fish ruled the waters, when the land was dominated by giant ferns and towering fungi, when the very first vertebrates were making a daring transition, trading gills for lungs, fins for limbs. These creatures, known as tetrapods, were the pioneers of land. They crawled from the water, struggling to breathe, fighting to survive in an environment where no vertebrate had ever walked before. But not all of them would remain on land forever. Some found a way to exist in both worlds. Some would evolve into a lineage that would one day become frogs. The first true ancestors of frogs appeared during the Carboniferous period, over 300 million years ago. They were not frogs as we know them, but they bore the first signs of what was to come. Short bodies, long legs, and ability to leap instead of walk. They were amphibians, creatures that lived between two realms, returning to the water to lay their eggs, yet venturing onto land to hunt. As the Earth changed, so did they. The climate shifted, continents drifted, and mass extinctions wiped out entire species. But through every catastrophe, Through every upheaval, these early amphibians endured. They adapted. They refined their abilities. And slowly, across the eons, they evolved into something new. By the time the first dinosaurs appeared in the Triassic period, the ancestors of modern frogs had already established themselves. Fossil evidence tells us that one of the earliest true frogs, Triadobatrachus, lived around 250 million years ago. This ancient amphibian was different from the frogs of today. Its body was longer, its tail not yet fully lost, but it had begun to develop the powerful hind legs that would define its descendants. Over the next millions of years, frogs spread across the globe. They survived the mass extinction that wiped out the dinosaurs. They endured ice ages, volcanic eruptions, and the rise and fall of entire ecosystems. They adapted to deserts, to rainforests, to mountaintops and swamps. But even as they changed, they remained connected to their past. Unlike reptiles or mammals, which had severed their ties to water, frogs never did. They still lay their eggs in ponds and streams. Their young still hatch as aquatic larvae before undergoing a miraculous transformation into their adult forms. And that transformation, that process of renewal, of rebirth, is one of nature's greatest wonders. Because while most frogs hatch from eggs, there are others that bring life into the world in ways almost unimaginable. Some frogs guard their eggs with fierce determination. Others, in the deepest parts of the rainforest, give birth to live young, skipping the tadpole stage entirely. There are even frogs that swallow their own eggs, allowing them to develop inside their bodies, only to later release them, fully formed, from their own mouths. How did these strange, diverse methods of reproduction evolve? How do frogs ensure the survival of their young in the harshest of environments? To answer that, we must dive into one of the most fascinating aspects of their existence, the incredible, varied, and sometimes shocking ways in which frogs bring new life into the world. How frogs reproduce: eggs or live birth. For millions of years, frogs have carried forward one of nature's most fascinating and mysterious traditions, the act of reproduction. It is a process that ties them to their ancient ancestors, yet within it, evolution has crafted an astonishing array of survival strategies. Some are simple, others are bizarre, and a few almost defy belief.
Most frogs begin life in the same way, in a story as old as time itself. A male calls into the night, his voice cutting through the darkness, a signal, a plea, a challenge. He is not alone. Hundreds, sometimes thousands, of others join him, a deafening chorus of competition. The sound carries over vast distances, reaching the ears of a female, hidden among the leaves, beneath the water's surface, or perched high in the canopy. She listens, she judges, and she chooses. Once she selects a mate, the pair engages in a delicate ritual known as amplexus. The male, often much smaller than the female, clings tightly to her back, his forelimbs locked around her body. It is a position that may last for hours, even days, as she prepares to lay her eggs. For most species, this is where life begins, in the water. The female deposits her eggs in clusters, in strings, or in delicate floating rafts. The male fertilizes them externally, releasing his genetic contribution into the water, where it mingles with hers. And then, the waiting begins. The eggs, soft and vulnerable, are left to fate. Some will be hidden beneath leaves, others clinging to parts of Africa, a few species of frogs give birth to fully formed young, skipping the tadpole stage completely. These frogs have rewritten the rules of their kind, proving that even within the constraints of evolution, nature will always find a way. And so, from the depths of ponds to the tops of trees, from the warmth of a father's mouth to the impossibility of live birth, frogs have mastered reproduction in ways that defy expectation. But once a froglet takes its first breath, once it stretches its delicate limbs and begins its journey into the world, another question arises. What will it eat? How does a tiny, newly formed creature, no bigger than a raindrop, grow into a hunter? Because frogs are not just survivors, they are predators. And their diet, their hunting techniques, their role in the ecosystem, these are what make them some of the most efficient killers in the animal kingdom. What frogs eat. From the moment a young frog emerges into the world, its survival depends on one thing: food. A tiny, fragile creature, no larger than a raindrop, must quickly learn to hunt, to grow, to strengthen its body before it becomes prey itself. But what do frogs eat? How do they hunt? And what role does their diet play in the delicate balance of nature? At first, a newly hatched tadpole knows nothing of the world beyond the gentle sway of water. It clings to life in the safety of shallow pools, its tiny mouth scraping against algae-covered rocks. In these early days, it is a plant eater, surviving on the microscopic life forms that coat the surfaces of its surroundings. But this phase does not last long. As the tadpole grows, so too does its appetite. Tiny aquatic insects become its next source of sustenance. Mosquito larvae, microscopic crustaceans, even the eggs of other amphibians. It is a shift in diet that signals a deeper transformation, because the moment a tadpole begins consuming living prey, it is no longer just a passive swimmer in the water. It is becoming a hunter. And then something extraordinary happens. The tail shortens, limbs emerge, lungs develop. The once waterlogged creature now takes its first breath of air, pulling itself onto the land. It has completed the first great transformation of its life. But with this change comes a new challenge, finding a companion entirely different. From this point forward, a frog is a carnivore, and its menu is as varied as the environments it inhabits. Most species feed on insects, beetles, crickets, flies, and moths, anything small enough to fit inside their mouths. But frogs are not passive feeders. They are highly specialized ambush predators. A frog does not chase its prey. It waits, perfectly still, nearly invisible, and then, without warning, it strikes. Its tongue, one of the fastest moving muscles in the animal kingdom, shoots out in the blink of an eye, coated in a secretion that changes its texture upon impact. At first, it is liquid, spreading over the prey, coating it completely. But the instant the frog retracts its tongue, the saliva becomes thick and sticky, like glue, ensuring that whatever has been caught has no chance of escape. Some frogs take this hunting strategy to the extreme. The Pac-Man frog, named for its enormous mouth, devours anything that moves, including small rodents, birds, even other frogs. Its bite is so powerful that once it clamps down, it is nearly impossible for its victim to break free. In the rainforests of South America, the legendary horned frog waits beneath the leaf litter, its camouflaged body blending seamlessly with the forest floor. It remains motionless for hours, sometimes days, until an unsuspecting lizard or snake wanders too close. Then, with lightning speed, it lunges, its jaws snapping shut with a force capable of overpowering creatures almost its own size. And in Madagascar, one species of frog does something filthy as well. It feeds on plants. While the vast majority of frogs are strict carnivores, a species known as Xenohyla truncata has been observed eating fruit, making it one of the only frogs known to incorporate plant matter into its diet. It is an evolutionary anomaly, a glimpse into the possible future of amphibian survival. But a frog's diet is more than just a means of survival. It plays a crucial role in maintaining ecosystems. By consuming vast numbers of insects, frogs help control populations of pests, preventing outbreaks that could devastate crops or spread as something delicate, fragile, and unformed. A tiny speck of life floating in the water, waiting for its moment to awaken. A single female can lay hundreds, sometimes thousands, of eggs at a time, clustering them together in gelatinous masses that drift near the surface of ponds, lakes, and slow-moving streams. These eggs, so vulnerable, so exposed, are the beginning of an ancient cycle that has remained unchanged for millions of years. But this is a dangerous time. Fish, insects, even other amphibians patrol the waters, searching for an easy meal. For every mass of eggs laid, only a fraction will survive. Nature is ruthless, and only the strongest, the luckiest, will make it past this first treacherous stage. And then, something miraculous happens. Within days, sometimes weeks, life stirs within the eggs. A dark speck wriggles inside its transparent shell, its tiny body twisting, pulsing, growing stronger. Until suddenly, the shell ruptures, and a new creature enters the world. Not a frog, not yet. A tadpole, a limbless gilled swimmer, no different from a fish, born to navigate a water-bound world. At this stage, it is completely dependent on its environment, feeding on microscopic plants, scraping algae from rocks, and avoiding the countless predators that lurk beneath the surface. But nature has given it a secret weapon. Even at this vulnerable stage, the tadpole possesses remarkable adaptability. In some species, if food becomes scarce, they will turn on each other, evolving into cannibalistic forms that prey on weaker siblings. It is a harsh reality, but one that ensures only the fittest will continue the journey. And then, the body begins to change. Almost imperceptibly at first, but then rapidly, undeniably. Tiny buds emerge where there was once nothing. Legs, arms. The tail begins to shrink, absorbed back into the body, repurposed for the next phase of life. The gills fade, replaced by lungs.
The eyes shift, the mouth widens. The entire body reshapes itself into something entirely new. It is a transformation so profound, so complete, that if one were to witness it without knowing the creature's origins, they might never believe that this was once the same being. The tadpole has disappeared, and in its place stands a frog. But this moment, this emergence onto land, is not the end. It is the beginning of an entirely new battle. Now the young frog must learn to hunt, to evade predators, to navigate a world it has never known. Unlike its time in the water, where food was plentiful and movement was unrestricted, survival now depends on skill, instinct, and speed. And even now, the transformation is not over. Many species continue to grow for months, even years, reaching full maturity only after surviving the perils of their environment. Some will grow larger, developing specialized adaptations that allow them to thrive in extreme conditions. Others will remain small, blending into their surroundings, relying on camouflage and stealth to stay alive. This is the life cycle of a frog, a journey from water to land, from defenseless to predator, from one form to another, in a continuous loop that has repeated since long before humans walked the earth. It is a story of survival, of resilience, of constant adaptation. But once these frogs emerge, once they take their place in their environment, how do they interact? Do they communicate? Do they warn each other of danger? Do they call to one another across the darkness of the night? The answer, as it turns out, is far more fascinating than we ever imagined. How frogs communicate with each other frogs do not have words. They do not write messages, they do not gesture like primates, and they do not share facial expressions the way humans do. And yet, across the dense jungles, the vast wetlands, and even the quiet backyard ponds, they speak to one another in ways that are as complex as they are mysterious. In the dark of night, a chorus begins, a deep, resonant croak, a rapid, rhythmic trill, a sharp, piercing chirp. Each sound, each call has meaning. Each is a message sent into the night, carrying vital information that can mean the difference between survival and death. At its core, frog communication is a battle cry, a love song, and a warning, all wrapped into one. Males, the primary vocalists in the amphibian world, use their calls to do one thing above all else, to be heard. In the wild, volume is power. The louder the call, the stronger the frog. And in the competition for mates, only the strongest, the most persistent, will succeed. But how does a creature so small produce a sound that can travel for miles? The answer lies in a remarkable piece of anatomy, one that turns their entire body into a living amplifier. The vocal sac, a thin, flexible membrane located just below the mouth, is the secret behind a frog's incredible sound production. When filled with air, it swells to several times the size of the frog's head, vibrating rapidly as it forces sound waves outward. Some species produce deep, guttural bellows that can be heard across an entire lake. Others create high-pitched whistles that cut through the dense air of a rainforest. Each species has its own unique call, so distinct that even in the chaos of a nighttime chorus, potential mates can identify exactly who is calling. But these calls are not just about attraction. They are also about defense. In a world where nearly everything is a predator, snakes, birds, mammals, even other frogs, communication is key to survival. Some species, like the Tungara frog of Central and South America, use their calls to deceive. Their mating call includes extra notes that make them sound larger than they actually are, scaring off rival males before a fight even begins. Others, like the poison dart frogs, use bright colors and warning calls to signal their toxicity, ensuring that predators think twice before making a deadly mistake. And then, there are the silent ones. Not all frogs rely on sound alone. Some, like the glass frogs of the Amazon, use body language, vibrating their legs against leaves to send signals through the forest floor. Others communicate through chemical cues, releasing pheromones into the water to alert their kind of danger, territory, or readiness to mate. But perhaps the most fascinating aspect of frog communication is how it is being disrupted. Across the world, human activity is drowning out their voices. The hum of traffic, the roar of deforestation, the pollution of waterways, it all interferes with the delicate balance of their world. In some regions, the once deafening chorus of frogs has fallen silent, and that silence is a warning, because when the calls stop, when the frogs vanish, it is not just their voices we lose. It is an entire ecosystem unraveling, a sign of deeper, more devastating changes taking place in the world around us. So, the question must be asked, are frogs disappearing from the Earth? Are we witnessing the decline of one of the planet's oldest and most resilient species? And if so, what does that mean for the future of our world? Are frogs vanishing from Earth? For millions of years, frogs have thrived on this planet, adapting to the ever-changing landscapes of Earth. They have survived mass extinctions, outlived the dinosaurs, and evolved into over 7,000 distinct species, each uniquely suited to their environment. From the rainforests of the Amazon to the swamps of North America, their calls have filled the night air, a living testament to nature's resilience. But now, a troubling silence is creeping in. Frogs are vanishing, and they are vanishing at an alarming rate. Across the globe, scientists have been documenting a crisis unlike anything seen before. Entire frog populations are disappearing, some so suddenly that researchers return to once thriving habitats only to find them eerily empty. The question is no longer if frogs are in danger, but why they are facing one of the greatest threats to their existence. And what does their disappearance mean for the world around us? Frogs are known as bioindicators, creatures that serve as nature's early warning system. Their delicate skin, which allows them to breathe and absorb water directly from their surroundings, also makes them highly sensitive to changes in their environment. When frogs begin to disappear, it signals that something is deeply wrong, not just for them, but for the ecosystems they help maintain. One of the biggest threats to their survival is habitat destruction. Wetlands, forests, and riverbanks, once teeming with amphibian life, are being drained, logged, or paved over at an unprecedented pace. Urban expansion and deforestation are erasing the very environments these creatures need to survive, leaving them with nowhere to go. But habitat loss is only part of the story. There's another deadlier enemy lurking in the shadows: disease. A microscopic fungus known as Batrachochytrium dendrobatitis, or chytrid fungus, has been sweeping across continents, wiping out entire species in its path. This highly contagious pathogen attacks a frog's skin, disrupting its ability to breathe and regulate essential bodily functions. Once infected, death is almost certain. Some scientists believe it to be the most devastating disease ever recorded among vertebrates, and its spread has only been accelerated by global trade and climate change. And then there's pollution, pesticides, and chemicals, many of which end up in the very water frogs depend on, are altering their biology in shocking ways. Some studies suggest that even low levels of exposure to these pollutants can cause severe deformities, hormonal imbalances, and reproductive failures. In some regions, male frogs are developing female characteristics, disrupting breeding cycles and further pushing populations toward collapse. Climate change is yet another silent killer. Rising temperatures and erratic weather patterns are altering breeding seasons, drying up once reliable water sources, and pushing species beyond their limits. Many frogs rely on precise environmental cues to reproduce, and when those cues shift, entire populations can be thrown into disarray. The loss of frogs is not just a tragedy for these remarkable creatures, it's a warning sign for the planet. Frogs play a crucial role in maintaining ecological balance. They control insect populations, keeping disease-carrying pests like mosquitoes in check. They serve as a food source for countless predators, from birds to fish to mammals. Without them, entire ecosystems could unravel. But is there hope? Conservationists and scientists are racing against time, launching breeding programs, tracking infections, and restoring habitats in an effort to save these vanishing species. Some frogs have been relocated to biosecure facilities, shielded from the threats that plague them in the wild. Others are being reintroduced into carefully protected environments in the hope that their populations can recover. Yet, despite these efforts, the crisis continues to escalate. Some species have already been lost forever, fading from existence before they were even fully understood. Others teeter on the brink, their future uncertain. Which frog species are most at risk of vanishing? Frogs, those small, resilient creatures that have roamed the earth for over 200 million years, are now facing an uncertain future. They have survived mass extinctions, outlived the dinosaurs, and adapted to nearly every environment on the planet. But today, they are disappearing at an alarming rate. The question is, why? Scientists estimate that frog populations worldwide have declined by nearly half over the past few decades. In some regions, species that were once abundant have completely vanished. But what is causing this crisis? The answer is not simple.
It is a combination of factors, each more threatening than the last. One of the biggest culprits is habitat destruction. Wetlands, forests, and rivers, once teeming with frog life, are being drained, polluted, and destroyed to make way for urban development and agriculture. Frogs, being amphibians, rely on both land and water to survive. When one is lost, their entire existence is threatened. But it does not stop there. Climate change is shifting temperatures and altering rainfall patterns, disrupting breeding cycles and pushing species beyond their limits. Some frogs, highly specialized to their environments, simply cannot adapt fast enough. Droughts dry up breeding pools. Rising temperatures push them to higher altitudes, where resources are scarce. Their once stable ecosystems are now battlegrounds for survival. Then, there's the silent killer, disease. The deadly chytrid fungus has swept through frog populations worldwide, infecting their skin, suffocating them, and causing massive die-offs. It spreads quickly, leaving devastation in its wake. Some species have been conservation efforts are underway. Scientists and environmentalists are racing against time, breeding endangered species in captivity, restoring habitats, and searching for ways to combat deadly diseases. The question remains, will it be enough? Because if frogs disappear, it's not just the animals. Frogs play a crucial role in maintaining ecological balance. They control insect populations, serve as food for countless predators, and act as pollinators, really alongside environmental distress. Through deployed series of devices, unlike other frogs, frog defense mechanisms. Frogs may seem harmless, small and fragile, but nature has equipped them with an astonishing arsenal of defense mechanisms, each uniquely adapted to handle the environment. When faced with danger, these seemingly harmless amphibians transform into masters of survival, some relying on deception, others on brute force, and some wielding toxins so potent they can kill with a single touch. One of the most well-known defense strategies is camouflage. Many frogs are born with the gift of invisibility, blending so perfectly into their surroundings that they become nearly impossible to detect. The Vietnamese mossy frog, for example, has skin covered in bumps and ridges, resembling a piece of moss or bark, tricking predators into looking right past it. Others, like the Amazonian glass frog, take a different approach. Their translucent skin allows light to pass through, making them appear almost invisible against the leaves they rest on. But when blending in isn't enough, some frogs take the opposite approach, warning their enemies with bright, striking colors that scream, "Stay away." Poison dart frogs, found in the rainforests of Central and South America, are some of the most vibrantly colored animals on Earth. Their electric blues, fiery reds, and neon yellows aren't just for show. They are nature's way of advertising danger. These frogs produce lethal toxins in their skin, powerful enough to kill anything that dares to take a bite. Indigenous tribes have even used their secretions to coat the tips of blow darts for hunting, giving these tiny creatures their name, poison dart frogs. But not all frogs rely on poison to defend themselves. Some turn to brute strength and intimidation. Budget's frog, also known as the hippo frog, is a prime example. When threatened, it puffs up its body to appear larger, opens its mouth wide, and emits a loud, almost demonic screech, startling predators into retreat. Other frogs, like the pack frog, have powerful jaws lined with sharp ridges, allowing them to bite down with surprising force, delivering a painful hurt to anyone foolish enough to get too close. Then, there are these frogs that use speed and agility to outmaneuver their attackers. The rocket frog, for instance, can launch itself over 6 feet in a single bound, making it nearly impossible for predators to catch. And the waxy monkey tree frog has an entirely different strategy. It produces a special wax that it smears over its skin, protecting itself from dehydration and making it difficult for predators to get a grip. Perhaps the strangest defense mechanism of all comes from the hairy frog, also called the wolverine frog. When cornered, this bizarre amphibian breaks its own toe bones, forcing them through its skin like retractable claws, creating a deadly natural weapon. Once the threat is gone, the bones retract, and the wounds heal over time, a self-inflicted injury that gives this frog a terrifying edge in battle. From vanishing into the background to deploying chemical warfare, from screaming like a banshee to launching surprise attacks, frogs are far from defenseless. They are survivors, shaped by millions of years of evolution to endure and overcome the threats they face. Frog mating calls. Why do they call? As night falls over the wetlands, a strange symphony begins. The air vibrates with an otherworldly chorus, rising and falling like waves against the shore. This is the sound of frogs calling, an ancient, instinctive melody that has echoed across the earth for millions of years. But why do they call? What secrets are hidden in these rhythmic, pulsing croaks, whistles, and trills? Frogs do not simply call into the night without purpose. Their voices carry messages, each sound a deliberate signal, a vital part of their survival. At the heart of it all, their calls serve one primary purpose: mating. It is a battle of sound, a competition where only the strongest, most persistent, and most enticing voice will win. Male frogs call to attract females, each species with its own unique sound, crafted through the delicate Frogs are highly selective when it comes to choosing a mate. Female frogs do not simply go for the first voice they hear. Instead, they listen carefully, tuning in to qualities that indicate strength, health, and genetic fitness. A deep, resonant call often signals a larger, stronger male, one more likely to produce robust offspring. Some species even favor complexity, drawn to males that can weave intricate patterns of sound, proving their endurance and vitality. But the language of frogs is not just about attraction, it is also about territory and dominance. Males use their calls to establish boundaries, warning rivals to stay away. In crowded breeding sites, a single night can become a fierce competition. Dozens or even hundreds of males compete at once, each trying to outdo the others. Some frogs, like the green tree frog, will even change the pitch and tempo of their calls to confuse competitors, making their voices stand out in chaotic chaos. Remarkably, some species have evolved to use their calls in unexpected ways. The Tungara frog of Central and South America, for instance, adds a special chuck sound to its call, a vibration that makes it irresistible to females. But this same chuck also attracts predators, including the frog-eating bat, which has learned to hone in on the exact frequency of the call. It is an evolutionary arms race, where sound can mean both the promise of new life and the threat of sudden death. Beyond mating, frogs use vocalizations to communicate distress, alert others to danger, and even coordinate movements. Some species, like the wood frog, have specialized calls that warn of approaching predators, while others, such as the African clawed frog, use underwater vibrations to send messages through murky waters where sound cannot travel as easily. The world of frog communication is a marvel of nature, an intricate, dynamic system shaped by millions of years of adaptation. It is a language woven through evolution, where each call carries not just sound, but survival itself. And as we listen to these nocturnal songs, we are hearing echoes of the past, voices that have rung out since the time of the dinosaurs, a reminder of the resilience and beauty of life on Earth. Conservation efforts to save frogs. Throughout the ages, frogs have played a vital role in maintaining the delicate balance of our ecosystems. They are nature's pest controllers, devouring insects that would otherwise devastate crops and spread disease. They serve as a crucial link in the food chain, nourishing countless predators. Even in the field of medicine, their skin secretions have led to groundbreaking discoveries. But despite their importance, frogs are disappearing at an alarming rate, and the battle to save them has become one of the most urgent conservation efforts of our time. The threats facing frogs are vast, complex, and often invisible to the untrained eye. Habitat destruction is among the most significant dangers. As human populations expand, forests, wetlands, and rivers are drained, paved over, or polluted, robbing frogs of the very environments they need to survive. Climate change adds another layer of peril. Rising temperatures alter breeding patterns, disrupt food sources, and push some species to the brink of extinction. Yet, perhaps the most insidious threat comes in the form of a silent killer, chytridiomycosis, a fungal disease that has wiped out entire frog populations across the globe. This deadly infection, caused by the Batrachochytrium dendrobatitis fungus, spreads rapidly through moist environments, attacking the skin of amphibians, the very organ that allows them to breathe and regulate moisture. It has driven numerous species to extinction, and despite years of research, there is still no clear way to eradicate it in the wild. Pollution, too, takes a devastating toll.